Hi all, and I welcome you to my YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to have a discussion on the chapter Relations and Functions of first PUC. Before I go ahead, please understand that I will be taking the concept and then itself I'm going to solve the model question paper problems. Okay, so don't think no at the end we have all the problems solved. Okay, and kindly make sure watch the entire video, only then you'll be having the better understanding. Okay, and this chapter, after I have finished sets, I have taken this chapter, and this chapter is a primary chapter for first PUC as well as second PUC throughout the other chapters. So I would like to surely give a detailed concept and then simultaneously solve the model question paper problems. So with this, let us start the chapter Relations and Functions. To be specific, let us write here first PUC, because we have in second PUC also this chapter. So second PUC already uploaded. Now let us try to understand the concept. Before we go to relations, primary thing we have to understand, and that is Cartesian product. Now what is this Cartesian product? Pay attention, listen carefully. Let us suppose that we have two non-empty set, and those two non-empty set is A and B. So I hope after watching chapter 6, you should be very clear that this symbol stands for what? Empty. I'm saying A should not be equal to empty set. Similarly, B should also not be equal to empty set. If this thing is there, then we are going to have A cross B. This cross represent is a Cartesian product. Coming to chapter 6, if you have this symbol, it is union. If you have this symbol, it is intersection. And this symbol, it is difference. And for this symbol, it is complement. All these four in detail we have discussed in chapter 6. Okay, kindly watch that video to have a better understanding of this chapter. Okay, now A cross B is set of all ordered pair such that the first element X come from the first set and the second element Y comes from the second set. And this X comma Y, whatever we have written here, this we call ordered pair. And in this ordered pair, X is called as first element of the ordered pair, and this Y is called second element of the given ordered pair. Now let us try to understand this with the help of an example. Okay, dear students, I have taken an exercise problem. I thought in place of giving my own example, I'll try to take the problem from the exercise as well. Exercise 2.1. Let us try to understand with the help of this exercise problem, how are we going to compute Cartesian product, and then again we are going to go ahead with the concept. Okay. Now, question says find G cross H and H cross G. Coming to the solution of this, G and H, as you can see, both are non-empty set. So I want G cross H. So what is set G? 7, 8. Then cross, what is H? 5, 4, 8. Sorry, 5, 4, 2. Now let us pair them up. See, when you are pairing, no, none of the elements should be missed. So how to make sure that none of the elements should be missed? Just very simple. From the first set, fix the element and pair with all. After you complete with the first element pairing with all of the second sector, then you can go for the next element. Like this, no, none of the element will be missed out. Now just see carefully. I'm taking 7. 7 I'm going to pair with 5, then 4, and then 2. So I'm going to have 7, 5, then 7, comma 4, then 7 comma 2. Okay. Now with 7 I have paid all the 3 elements. Now it is paid 8. 8 comma 5, then 8 comma 4, and then 8 comma 2. Let us take that. 8 comma 5, 8 comma 4, then 8 comma 2. That's it. This is your Cartesian product G cross H. Now question says also find H cross G. So let's find H cross G. So coming to this again, what is, let us do one thing. Let us substitute what is H and G. Okay, H is 5, 4, 2. Here the order is important. First here H is there, so let's set H which is 5, 4, 2. Then cross G is 7, 8. Now again pair them up. Fix this first element 5 and pair with this. So what we are going to have, 5 comma 7, 5 comma 8. Then what next? 4 comma 7 and 4 comma 8. Then 2 comma 7 and 2 comma 8. Let us write this 2 properly. So that's it. We have completed the problem, and this is how you are going to find the Cartesian product. Now having understood this, let us understand some of the points. I'll take in the form of a note. Now the first thing about the note, see carefully. We are talking about ordered pair x comma y. Under what condition we say that this ordered pair are equal? So two ordered pair x comma y is equal to a comma b. This double implication stands for if and only if. Okay, let us write in bracket, if and only if. And this also in short form we write as IFF. Okay, so this ordered pair are said to be equal if and only if. Okay, write again here, if and only if. Okay, first element is equal to first, nothing but x is equal to a. Second element is equal to second. Only then we say the two ordered pairs are equal. Now one question will come, sir, why it is so? And here let us try to understand this with the help of geometry. Geometry is the key to understand this chapter still more better. Yeah, let us understand this with the help of geometrical interpretation. So geometry let us interpret this in geometry part. Okay, then the things will be very clear. I am taking x and y axis, and this we call Cartesian plane. So you can see from here itself Cartesian plane I am saying, and here we have got Cartesian product. So geometrically each of this represents a point. Okay, so if I just take some number on x axis followed by y axis, then some negative number. Yes. Now if I talk about a point 1 comma 2, see, whenever we talk about any point, first is x coordinate followed by y coordinate, correct? No? So 1 comma 2, x value is 1, y value is 2. So somewhere here 1 comma 2, this is the point. Let us suppose the point is P. Then let us talk about one more point, 2 comma 1. When I say 2 comma 1, x value is 2 and y value is what? 1. 2 comma 1 here, point Q. Now see very carefully, is, now for this 2 coordinate, when I have taken P is equal to 1 comma 2 and Q is equal to 2 comma 1. Can you see? Is 1 is equal to 2? No. Is 2 is equal to 1? No. Why is that? Now I want you to understand why is that this condition should be true for this 2 coordinate, or I can say the ordered pair to be equal. Reason is here. Now since these two are different, you can see the points are two distinct points, two different points. They are the same point. If at all I got again 1 comma 2, it will be here, or again 2 comma 1, it will be here. Okay, even if I take 1 comma 1, you see here 1 comma 1. Here x coordinates are same, but y coordinate is different. See, for this two, y coordinate is same, but x coordinate is different. So that's the reason both first element x with A, second element y with B should be same. Only then we say ordered pairs are equal. Okay. Now, having understood this, let us come back here. What do we think whether these two sets are equal or not? Because for that to compare, no, I have just defined this ordered pair when to be equal. So here if you see the first ordered pair, recall from the chapter 6, when do we say two sets are equal? All the elements should be same. All the elements should be same. Now 7 comma 5, we have 5 comma 7. For this to be equal, first element and second element should be same. No, they are different. Again here also you see 7 comma 4 is same as here. For this you have 4 comma 7, but both are different. So all the elements are different. So from here we can say that in general, what? A cross B is not equal to B cross A. One point here. I said in general. It means there is a chance that it can be equal also. Yes. Yes, it is equal. See, but A cross B is equal to B cross A if and only if both are what? Equal sets. Here also I should have the same. 7, 8. Then both will be what? Same. Okay. Next. So from here I can also conclude that G cross H is not equal to H cross G in general. Okay. Next. Let us try to understand here. No, we wrote the element. So simplified and got the answer. Just count how many elements do we have in G cross H. See carefully this. How many elements do we have in this? And how many elements do we have in H cross G? Count 1, 2, 3, 4, 5, 6. Yes, 1, 2, 3, 4, 5, 6. So the next point, even though the sets are different, A cross B and B cross A are here, G cross H and H cross G are different. I'm just trying to write in terms of A and B. You can write in whichever way we want, okay, whichever letter we want. So here we can say number of element in A cross B is same as number of element in B cross A, and this we can also understand as number of element in A into number of element in B. See carefully here. Both we have 6, we have just now counted. So number of quantities are same. Sets are different. Quantities are same. Now you see in G, how many are there? 2 elements. In H, how many are there? 3. 2 into 3, 6. And here also we count 1, 2, 3, 4, 5, 6. And here also 1, 2, 3, 4, 5, 6. That's what we're commenting that number of element in A cross B is same as number of element in B cross A, which we can obtain by multiplying number of element in A and number of element in B. This can be a very easily 1 marker question. Let us suppose I have given you this and I'm asking number of element. In place of finding like this, yeah, here we have 2, here we have 3, 2 3s are 6. Job done. Okay. Next. Having understood this, next point, under what condition this cross product will be finite or infinite? Let us have a discussion here. See carefully. A cross B is finite. First I am talking about finite. See carefully. Is it not this H cross G and G cross H? Finite means what? Number of elements should be countable. It should not be infinite set. We should be able to definitely give a number. How many elements are present? So these two are finite because G is finite and H is finite. So I can say from here A cross B is finite if and only if both A and B are what? Finite. Then what about A cross B is infinite? Under what condition it will be infinite? Now let's see for a while. Now for a while you think here H is equal to, you have 5, then 4, then 2 and dot 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 infinite set. For a while you think. Then what happened? 7 will pair with all the elements. Now see, when 7 itself is pairing with all the elements, since this has got infinite set, 7 will be paired with infinite number of elements. Similarly 8 also. So here one set is finite, other set is what? The infinite here. So A cross B is infinite if either A, the set A, or set B is infinite. If any one of them is also infinite, then A cross B will be finite. I have used the word either. It means it can be A, B, or it can be both also. Okay, then it will be infinite. So I hope this concept is clear. Okay, kindly make a note of the same. I just comment on cross product between empty set and non-empty set here itself. Let us have all together at once. See carefully. What will be cross product? If at all cross product between the two set is empty, then what can we comment? So again, you see here far away. Okay, let's take an example here. So A is equal to 1, 2. And let us suppose B is empty set. Then what could be A cross B? Now I have to pair, as you know, for A cross B, first element, the element of the first set should be paired with the element of the second set. So first set A is A, element is 1. Are we able to pair with any of the element? No, because it is empty set. So I'll get cross, means it will be empty. So cross product is empty if either A or B is empty set. Any one should be what? Empty set. If any one of them is empty set, only then we can see that cross is what? Empty. So having those understood, let us take problems from model question paper on Cartesian product. Kindly make a note. Okay, dear students, having understood the concept of Cartesian product, now time has come to solve problems from model question paper. So as I said, I'll be going concept wise to solve the model papers. So coming to model question paper number 1 of the academic year 2024-2025 issued by PU board. Part A from first model paper, 1 marker question, MCQ, says 1 marker question. If this ordered pair are equal, then find the value of x and y. So when do we say ordered pairs are same? First element of the first order pair should be equal to first element of the second order pair. So x minus 1 solution, x minus 1 should be equal to 1. Solve for x, transpose this, x is equal to 1 plus 1. When I transpose minus 1 will change to plus 1, sign will change. 1 plus 1, 2. Okay, but we can see in this option there is no 2, this option no 2, so option C and option A out. But since in both option B and D we have 2, we have to surely find the y value. Okay, let's find y value. So here y is in the second element of the first order pair. Equate this with 5. So y plus 2 is equal to 5. Transpose this. Y is equal to 5 minus 2, or y is equal to 3. Therefore, my ordered pair x comma y value is x is equal to 2 and y is equal to 3. 2 comma 3, option B is correct. So for this problem, option B is correct. Okay. Now, before we just go for the next problem, let's take the model question paper number 3. Again, it's an ordered pair. The only difference is this is from the fill in the blanks and we have a fraction. Okay. So we want only y value. Okay, fine. Y is the second element of the first order pair. So I'm going to equate with the second element. That's what concept is so important. Okay. Now y minus 2 by 3 is equal to 1 by 3. Now I have to solve for y. Difference of two terms. If I transpose, when I transpose, the sign negative will change to positive. What is here fraction? See, here we didn't have fraction. It was only a natural number. I can say integers rather. But here we have a fraction. Whenever we have a fraction, nothing but p by q form, then we have to surely take LCM if at all they are separated by sign plus or minus. So see the LCM of denominator. LCM of 3 and 3 will be 3 itself. 3 by 3 is 1. 1 into the numerator, that is 2. 2 ones are 2. Then 3 by 3 is 1. Again multiplied to the numerator. 1 ones are 1. So 2 plus 1 is 3 by 3. So 3 by 3 will get cancelled. Y value is 1. So for this value of y is 1. I'd like to see how many of you are going to comment in the comment box. What is the value of x? So finding the value of x is the assignment for you. Okay, that will be the assignment. Now let us come to model question paper number 2, question number 21. It says if A cross B is given, then find both sets A and B and then find B cross A. Now comes the concept of we discussed in Cartesian product that if I've got A cross B, it is set of all ordered pair A comma B such that first element A will come from the first set and the second element B will come from the second set. So having this information, let us try to solve it. Now see carefully which is the first set here? A. Now which are the first element in the order pair? A, again A, again A, then B, B, B. Since all are first element of the ordered pair, it should go to which set? First set. So first set is A and the element A and B are the element of that. Some might comment, sir, why not here A, comma, B, B, B. In chapter 6 we have discussed already, element should not be repeated, only once we are going to write, okay. Next, we have got A. Coming to B, how to get B? Again, B is, as you can see very carefully, B is the second set. So all the second element of the ordered pair will be from the set B. See carefully, B. Here, this is the second element of the ordered pair. Again, second element. Here also second element, and second element. So B is equal to here 1, 2, 3. Again here also 1, 2, 3, but element should not be written. Keep as it is. Now see, I want B cross A also. Fine, let us find it here. B cross A. What is B? Set B here 1, 2, 3. And set A is A comma B. Now let us try to pair them up. See carefully how we have to pair them up. Fix the first element of the first set and pair with all. Okay, so 1 I am going to fix, pair with this 2. So I am going to pair 1 comma A and 1 comma B. 1 comma A comma 1 comma B. Next 2 comma A, 2 comma B. 2 comma A, 2 comma B. Lastly what? 3 comma A, 3 comma B. 3 comma A, 3 comma B. That's it. This is B cross A. Does that properly? This is B cross A. That's our solution. So from all the three models, we can see surely question has come. And on this Cartesian product, we have completed. Okay. Let you take one assignment from Cartesian product. See, I just want to talk about triplet here. Triplet. What's the meaning of that? See, we have just spoken about Cartesian. They were having two sets. Let us suppose that I have got A cross A cross A. This is defined as A comma B comma C, such that, see, here the first element is A, first set is also A. So A, then B also A, C. A, B, C are coming from the same set A itself. And this we call triplet order. Okay. Now on this one assignment I want you to take is, if A is equal to 1 comma minus 1, then you have to find what is A cross A cross A. This is your assignment. Okay. First you find A cross A. Then you will get, since you have got two elements here, so A cross will have 4 elements. Then after finding A cross A, again pair with A, totally you will get 4 into 2, 8 elements, because A cross A will give you 4 elements. Again you have got A to be paired, so 4 in A cross A, 4 elements in A cross A and 2 elements in A. 4 2s are 8. Okay. All the very best, try to solve this. Dear students, having completed Cartesian product along with the model question paper problem, now time is for relations. Okay. Now let us try to understand and define. Before that, this chapter 5, okay, you can just say 8 plus is assured. Okay. 1 5 marker is also there. Okay. Along with 3 and 1 marker. So I just said 8 plus is assured. Okay. Now 8 plus marks I mean to say. Now let us move on to relation. What is a relation? Relation is first thing is it is denoted by capital letter R, and relation R is subset of Cartesian product A cross B. There will be some relationship between the element of the first set with the element of the second set, and this relationship is defined in the question itself. And it can also be equal. Now when it can be equal, if I define such a relation that all the element of R is same as A cross B, okay, then it will be equal. Now since R is subset of Cartesian product, so the element of this should be also what? Ordered pair A comma B form, where again A will come from the first set and small b will come from the second set. Okay. Now, having understood this, let's take one small example to understand the concept still more better. See, if I have got a set A and I would like to simultaneously give the understanding on functions also, that you have a difference between relations and function. So first, if I take A is equal to one set here, 8 minus 1, 0, and B, let us suppose 2, okay, and minus 3, okay. Let us have one more element, 1. So now, if this is given, then we have to find, first thing, let us again find A cross B. Then second thing is, we have to find set of all relation R such that the order pair x comma y, the condition here is x should be less than y. Okay. And as I said here, relation capital R is denoted. Even set of real number is also capital R. So one confusion will come, sir, how to know which capital R stands for relation and which stand for real numbers. See, the way I written, no, before the word relation, before the word R, the word relation will be specified. So there is a clear-cut idea we will get, okay, that this particular R stands for relation, not for the set real numbers. Now let us take the solution of this. Pay attention. Coming to A cross B, okay, we know how to find A cross B, just we have to pair them up. Let us substitute here. What is A? 8 minus 1, 0, then cross, and here it is 1, 2, minus 3. Now when I want to pair, see carefully. First element 8 paired with 1, so what I'll get? 8 should be paired with 1, so 8 comma 1, then 8 comma 2, lastly 8 comma minus 3. Similarly, paired with minus with all this, minus 1 comma 1, minus 1 comma 2, minus 1 comma minus 3. Last is 0. 0 comma 1, 0 comma 2, 0 comma minus 3. So this is A cross B. First part done. Let us highlight this. Second part is relation R. I should write only those order pair in which x is less than y. Don't forget, as per the concept, x will come from the first set, that is A here, and y will come from the second set. See, this one need not be mentioned. It's understood from the concept. Now R. Check one by one. If I take 8, I should see, is 8 less than any one of the element from second set B? Is it 8 less than 1? No. It is more than 1. Is 8 less than 2? No. Is 8 less than minus 3? No. So 8 cannot be paired with any one of the element as per this condition, less than. Okay, now take minus 1. Is minus 1 less than 1? No. Is yes? No. Yes. Then is minus 1 less than 2? Yes. Is minus 1 less than minus 3? Think for a while. See the number line? Minus 1 here, minus will be left. Always, simple logic. Always the left number is lesser than the right number. 0 somewhere here. Be careful, 1 is here and 3 somewhere here. Okay, always the left number is lesser than the right number. Okay. Next. minus 1, no, minus is 1, no, is not less than minus 3. Actually, minus 3 is less than this, or minus 1 is larger than minus 3. Now take 0. Is 0 less than 1? Yes. Is 0 less than 2? Yes. Is 0 less than minus 3? No. Let's check again. Is 8 less than any of this? No. Is minus 1 less than 1? Yes, I wrote. Is minus 1 less than 2? Yes, I wrote. Is minus 1 less than minus 3? No, you can see here. It always the left number is lesser than the right number. Okay, next 0. Is 0 less than 1? Yes. 0 less than 2? Yes. And but not with minus 3. Fine. Now see carefully. Observe the elements carefully. Can you see this element? Minus 1 comma 1 is present here. Can you see minus 1 comma 2? It is present here. Can you see 0 comma 1? It is present here. 0 comma 2 present here. That's what we said. R is subset of Cartesian product. Okay. Now, when it can be equal, if I define this as x less than y, x greater than y, or x equal to y. So all the three conditions I give, less than, greater than, or equal to, then what will happen? All this element will come in R. Okay. Now, that will be is equal to A cross B. Now, let us try to have one formula to find number of relation. See, since R is subset of A cross B, R can be empty also. Nothing but such a condition if I impose that none of the elements satisfy the condition. Okay. So, sir, can you have one condition as such? Yes. See carefully. If I define for clarity purpose, I'll take one third sub problem. If I define R is equal to ordered pair x comma y such that the difference between the two terms should be less than 0 under the mod. Under the mod, whenever we have any term, it is either positive or equal to 0 provided this term is 0. Correct? No? X minus y is 0, then I'll get 0. So always the modulus value is non-negative. I am saying I want only those elements. If I take difference and then take the mod, it should be less than 0. None of the element will obey. In that case, R is what? Empty set. So I have tried to convince you that R is subset of A cross B. When R is subset of A cross B, from chapter 6 we know that every set A will have empty set as well as the given set A to be subset. So here R also, every relation R will have empty set and as well as itself nothing but A cross B also can be the relation. So from this we come to a point. What could be the formula for number of relations? What could be the formula? Let us take as a note. Number of relations from set A to set B is given by 2 to the power of number of element in A cross B. This is again same as 2 to the power of number of element in B cross A, which is also same as number of element in A cross number of element in A into number of element in B. This is into symbol, not cross. After getting A and B element, you have to multiply. So one question will come: how many relation is possible from A to B? So for this, if I want to answer, so number of relation. So number of relations, okay, are 2 to the power of number of element in A into number of element in B. How many element do we have in A? 3. How many here we have? 3. 3 into 3 will be 2 power 9, which is 512 relations are possible. Okay, fine. Now let us try to understand some of the terminology associated with the relation. Now here, let us write this one again here. Okay, R is equal to, let us write all the things, set A, so that now we will have a better clarity. Set A is, I want you to understand this properly, because after this I am going to define function also. So A is being given, and what we have got R minus 1 comma 1, minus 1 comma 2, 0 comma 1, 0, comma 2. Let us cross check. Have written all the elements perfectly. Okay, fine. And A is also written. Okay, fine. Now I want to discuss three terms: domain, codomain, and the range. Okay. Now, for this to understand, the best way will be arrow diagram, which I call banana in our class. Set A and set B. What is set A? Elements 8, then -1, 0. What is second set element? 1, 2, -3. Now, domain. What is domain? It is set of all the element of the, I repeat, it is the set of all the first element of the ordered pair having an image. I mean to say, see this, -1, 1. So -1 is mapped to 1. -1, comma 2. So -1 is mapped to 2. 0, comma 1. So 0 is mapped to 1. Then 0, comma 2. So 0 is mapped to 2. So now, whatever the element is mapped here, that is here 1, comma 2, this we call images. Nothing but the set of images we call range. So here it is images. Now see carefully. -1 have got two images, that is 1 and 2. 0 have got two images, again 1 and 2. So what is domain? It is set of all the element of the ordered pair, first element of the ordered pair having the image. Now in this, only -1 and 0 have got the image. Therefore, the domain will be -1, comma 0. Because only these two have got image. 8 don't have any image. And this you can see subset of A. This is a very important difference when I come to functions. Okay. So here in relation, some of the element may not be having image. Okay, that you can see. And they may also have more than one image also. Next, codomain. What is codomain? It is entire second set B. Whose entire second set here? 1, 2, -3. That is your set B. Next comes range. What is range? Set of all the images. Set of all the images that is present in second set B. So what are the image? 1 and 2. And you see this range 1, comma 2 is containing B. So always it is subset of codomain. Range is always subset of codomain. And I would like to give as a note that range can be subset or equal to codomain. Can be equal to codomain. Now here, what are the things to be understood? First, coming to relation, there will be a particular relationship between the first element and the second element of the set A and B, ordered pair. Mean to say, I repeat again, there will be a relationship between first set element and the second set element in the form of an ordered pair. If it's obeying like this, only then we are going to write. Disobeying, we are not going to write. Now in that, all the first coordinate, in the first coordinate, the first element, let us have here. So whenever we talk about any ordered pair, if it is present in R, that's very important, then always the first element will give you domain and the second element always will give you what? Range. Simple as that. Okay, so that's what you can see here. -1, -1, 0, 0. Yeah, that's your domain. And 1, 2, 1, 2 is your range. And always the second entire set, whether it is having some image, it is not an image of any of the element here, all those, whether it is there or not, least bother, entire second set B is our codomain. Okay, so I hope this is clear. Before we take up the problem, I would like to discuss now itself functions to have a clear-cut idea. Okay, make a note of this. Let I just mention what this diagram is called, arrow diagram. Okay, let you know, I just said orally, but I didn't wrote. Arrow diagram. Okay, make a note kindly. And this is images. I is looking, I hope, properly. Images. Dear students, having understood relations, now let us move on to functions. I have written this one as it is because I want you to have a clear-cut idea difference between relations and functions. Okay. Now, what is a function? It is a special type of relation. I use the word relation. So it means every function is what? Relation. It is a special type of relation where every element have only one image, or I can say unique image. Let us write that. Function is a special type of relation where every element has one and only one image. When I mean to say that unique, it should be unique image. For example, let us understand this. If I'll just take 3 arrow diagrams, see carefully, and you have to judge whether it's obeying this condition or not. Okay, first example. I'll take the same element to have a better clarity. This is the first example. Let us suppose we are going to have this and one more. Okay, lastly we'll take one more here. First let's complete, then we'll take in case space is not sufficient. Okay, I can erase and write. Now let us say that I have got this. I will use the word presently relation only. Relation F1, relation F2, and it is F3. Now definition says every element should have only one image. Check. Every element is said. Not, it means what? Not even a single element from the first set should be missed. So this is set A, set B. For all it is set A and set B. So see carefully for first problem F1. 8. It has only one image, that is 2. -1 has only one image, that is 1. So both are satisfying the condition. But 0 don't have any image. I have used one word here, every element. Okay. So F1 is not a function. F1 is not a function as element 0, this 0 don't have any image, don't have image. Okay, don't have an image. Okay, IMAGE for a while, don't have an image. Okay, fine. Come to this. Before that, let's try to write domain of this. I want to have a clear-cut idea of a domain of this. What's the domain of this? 8 minus 1. What was the domain? Set of all the element of the first ordered pair. I repeat, set of all the element of the first set A, which is having the image. If I talk in terms of ordered pair, first element of the ordered pair having an image, having a image. Okay. It can have more than one image also for relation, no problem. So here 8 and -1 have got image, 0 don't have any image, so nothing to write. Next comes codomain. Coming to codomain, entire second set B, it is 1, 2, -3. Here the most important thing, no, it is this is subset, this one is subset of A. Okay, and codomain here range. See the range 1, 2, and again that is subset of codomain B. This is B. Now come to the second example. What do you think? Is it a function? Check one by one. Image of 8 is 2, only one image. Image of -1 have 2 images. -1 has got 2 images, namely 1 as well as -3. Therefore, -1, because of -1, F2 is not a function because -1 has got more than one image. Whereas 8 has got only one image 2, 0 have only one image -3. Okay, so F2 is not a function. Here every element has got an image, so this can is satisfied. But here no, one and only one image, that is not satisfied by -1, as -1 don't have unique image. Unique image, as it has 2 images. I'm giving the reason here, namely, which are the 2 images it has? 1 and -3. 1 and -3. Okay, is it recording? Yeah, recording. I had a doubt in this recording or not. Next, now let us try to write domain. What is the domain of this, dear student? 8 -1 0, because all have got the image, and it is equal to what? Set A only. Next, see codomain. Codomain is always the second set. Codomain is always the second set, that is 1 to -3. 1 to -3, all the element. And what is the range? 1 to -3. And that is equal to what? Codomain B only. Okay. Now here, what is the highlight point? No, domain part. For relation, domain can be subset of the first set, or it can be equal to the first set. Okay, let us try to understand this problem. F3, what do you think? Is it obeying this condition? Just check one by one. What is image of 8? 2, only one image. Image of -1, -3, only one image. Image of 0, -3. I know many students will be thinking that F3 is not a function. F3 is not a function, many will think, and the reason will be, sir, -1, 0 have got same image. Yeah, no problem. -1 and 0 have got same image. Read this definition. It is a special type of relation where every element should have a one image, one and only one image. We never spoke whether they should have same image or different image. So here, just go like this. How many image one has got? Image of 8. First I repeat. How many images, or what is the image of 8? 2. What's the count number of images? Only one for 8. Come to -1. How many image -1 has got? First, what's the image of -1? -3. How many image? Only 1. What's the image of 0? -3. How many image? Only 1. So all have got only one image. Therefore, F3 is a function. Having understood this, now let us move on to domain, codomain, and range. Coming to the domain, it is 8 -1 0, which is same as set A. Coming to codomain, 1 2 -3, nothing but the entire second set B. Next comes range. What is this? 2 and -3, set of all the images. And again, this is going to be subset of codomain B. Now here, the highlighted point for you is this. Whenever we say a function, no. See the difference between relation and function. As soon as we say a function, since every element should have an image, always the first set A becomes your domain. Always your first set A becomes your domain. Whereas in relation, no. You see, first set A need not be the domain. The element contained in set A is the domain. It may have subset of A may be a domain, or the set A itself may be a domain in relation. But coming to function, always the first set will be what? Domain. There is no chance that subset of A will be domain. If it is so, it will be this scenario, nothing but one element, minimum one element, it don't have image. But here we have said every element should have an image. So that's the basic difference. Next, as soon we say henceforth, let us try to make a note here. Henceforth, whenever we say f is a function from A to B, we are going to denote like this. F is a function from A to B, where A is called domain and B is called codomain. And I want to understand one more thing in this. See carefully. In this example, F3 is taking, you can just assume this one, that you are in college. Okay, this is your home and it's your college. You have to go from home to college. Okay, so you are in the place 8 and you want to go to the place 2. So to go from home to college, you have got many transport system, no? Either it can be bus, car, two-wheeler, or even by walk. Okay, bus number 11 we say, no, when we walk. So here, this is your transport. You are here and you want to go here. So see carefully. You are getting inside the bus F3. So you are getting, F3 is the bus and you are getting inside the bus F3. You are getting inside and this is taking to this direction. So equal. Similarly, here, see carefully. You are at a position -1. You are getting inside the bus and you are placed to a location -3. So F3 of -1. So for the same, we have F3 of 0 also. So what I want to say from here is, whenever you have got anything written in this form, the term which is present inside will be your pre-image. This we call pre-image. Set of all the element of the first set having the image, we call pre-image. What we call? Pre-image. And as we already discussed, all this are called what? Image. Okay, pre-images, I will just use here because there are more than one. Now, student have a confusion now. Sir, which is image, which is pre-image? As soon as you give two terms, we are having trouble. Very simple. Okay, before I go for this, no, first I will talk. In reality, do we have a difference between relations and functions in our real world? Do we have any example as such? Very simple. Just for a while, go to salon. And usually everyone will go to salon for haircut, etc. Correct? When you stand in front of the mirror, just recall how many images you can see about yourself. How many images? More than one. Why? One mirror is at the front, one is at the back, due to which we will see more than one image. This is an example of relation. Okay. Now come back to home. When again at home, when you are going to see the mirror in front of you, how many images you can see? Only one image. Correct now? Since you can find only one image now, so eye, only one pair of eye, head, forehead, nose, right, lip, correct? So only one image, nothing but this is an example of function. So in our real world problem also, we have relation and function. Go to salon, you will get example of relation. Come home back, you will get a function. Okay. Now how to differentiate this pre-image and image? Again, I'll take mirror example only. Let us suppose that you are set A and set B is the mirror. So when you are going to stand in front of the mirror, where is the image form? On the mirror, right? So image is on the mirror. That's what image. But you are the pre-image. You are the first image. You are the original image. First means pre-image. I hope this point is clear. Okay. Make a note. I would like to erase some of the content here and again have a revisit for this diagram. Make a note. So I have written this to have some more talk. Let us try to write down this in the form of a set. See carefully. F3. 8 is mapped to 2. So 8 comma 2. Minus 1 is mapped to minus 3. And 0 is mapped to minus 3. Now, I'll do one thing. Let I try to remove the subscript, okay? I will just write as F now so that I can have this discussion, okay? Fine? Now only F. I took F1, F2, F3 because I took 3 examples. Now I am confining with this. Now you see carefully, this is in the order pair, this is the first element, which is coming from the set A. This is the second element, which is coming from the second set B. Now, very clearly, when I talk about the domain, which is 8 minus 1, 0, I can always say that if I have an ordered pair, always my X is the domain, which we also discussed there. Same point I'm writing even for functions also. And this is your range. Having understood this, the one more point is, if I talk about this element, 8 comma 2 belongs to what? F. In place of writing like this, we write F of 8 is equal to 2. That's what I said here. No? Now here all these 3 are what? I have taken as F in place of F3, F now. So always the term inside here, this is your pre-image. And this entire, whether 2 or F of 8, both are what? Image. I hope this point is clear. Fine. Now, I just want to define 2 terminology, then we can go with the problems. Real function, real valued function. What is this? If I have got F is a function from A to B, then coming to real function, when I say real function, my domain set A should be a subset, or it can be equal to a set of real numbers. Don't forget set of real number. If I talk about natural number is subset of whole number subset of integer subset of rational number, this is subset of real number, as well as entire irrational number T or Q complement is subset of what? Real number. Okay. In NCERT we have this dash. Okay. Only dash. Now, this is for real function. One more is real valued function. When do we say it is real valued function? Again, if F is a function from A to B, whenever the codomain is set of real, subset of real number or set of real numbers, then it is real valued function. Throughout our first PUC, except complex number, our all entries, all the mathematical numbers will be under real numbers only. Okay? Fine. Let us take one last example. Here, minus 1 and 0 had same image. It can have different image also. I'll take one example on that, then we can start with the problem. Let us take one more example. Let us suppose fourth one. So here you see 1, 2, 3. Or I will take the same element, better. We'll take the same element, 8 minus 1, 0. I took the same element throughout, no, to have a clarity. Okay, let us suppose this is F4. Now, see this. Now, for this, no one will have a doubt. Yeah, it's a function. All elements have only one image. Here also, all elements have only one image, but minus 1 and 0 had same image. No problem with that. Okay. Okay. So, yes, it is a function. Okay. What is the domain? Again, the domain is the entire set 8 minus 1, 0. What about the codomain? Entire second set B, this is A to B. B is 1, 2, minus 3. Then lastly, range. What is the range? Again, all the images, set of all the images, 1, 2, minus 3. And this is equal to codomain this time. So that's what we said, no? It can be subset or it can be equal. But coming to domain is always the first set. Okay? So having this knowledge, let us go ahead and learn one last thing, no? So many times in the question, they will give this type of question and they'll ask, is it a function or not a function? Very simple. Whenever you see first coordinate in the coordinate, the ordered pair, first element you see 8 minus 1 0. Whenever these are not repeated, nothing but they have only one image. If it's repeated, then it has more than one image. So if it's repeated, not a function. Not repeated, it's a function. Okay. So let us have problems now. Make it out. Okay. One last thing. What I have said here. Let us have the same comment in general. So if at all I have got an element a comma b belong to f, same like this, then I will write f of a is equal to b. So where f is a function from a to b. Okay. So as I said, first set stand for domain, second stand for codomain. Okay. Okay. Yes, dear students, now it's time to solve model question paper problems on relations. Okay. So from part C, model question paper number 1, it's a 3-marker question. Question says, determine domain and range of the relation are defined by this. This is given in which form? Rule form. Correct? So now we have to write in roster form, list out the element, then it will be easy for us to comment. So see, this is of the form x comma y. So this entire thing, x plus 5 is what? Y. And the given x is coming from here. So one by one, put the value and obtain the y value. So this is my equation number 1. So when x is equal to 0, just see, when x is equal to 0, if I put in equation number 1, so I put here, what you are going to have, y is equal to, x is 0. So 0 plus 5 will be 5. So from here, x comma y. So when x is 0, y is what? 5. Okay. This is the first order pair. Next, when x is equal to, next element is 1. Put in equation number 1. So when I put in equation number 1 here, what happens? Y equal to 1 plus 5, which is what? 6. So when x is equal to 1, y is 6, 1 comma 6 is an ordered pair. Next, when x is equal to 2, in equation number 1, yeah, x is equal to 2 here. Okay, since 2 is there, I've taken 2. It's not that I can take my own value. All the values are from here, right? So when I put here y is equal to 2 plus 5 is 7. This working need not be shown in the examination. It's only for your clarity. Okay, next, x is equal to 3. Put in equation number 1. Why 3? Because 3 is there here. Put here y is equal to what? 3 plus 5 is 8. So this gives us, when x is 3, y is 8. 3 comma 8 belongs to R. Next, when x is equal to, next number is 4. When x is equal to 4 in equation number 1, what will you get? Y is equal to 4 plus 5 is 9. This implies 4 comma 9. Lastly, x is equal to 5. Now 4 over already. When x is equal to 5 in equation number 1, we will have y is equal to 5 plus 5, which is nothing but 10. So I'll get 5 comma 10 belongs to R. Okay, and I must check, is it recording? Yeah. No, always I'll have a doubt in between, because if recording is not going on, then all this working is going to be in vain. No. So this is my R, relation R for this question. So let us first write down 0 comma 5, then 1 comma 6, this 2 over, then 2 comma 7, 3 comma 8, then 4 comma 9, and lastly 5 comma 10. This is our relation R. Now we have to comment on domain and range. Don't forget, already we discussed, whenever you have any ordered pair and if it is present in R, that's important. First it should be present in R, then the first element will give you domain and the second element will give you range. Coming to codomain, entire second set B. Okay. So now here in this question, second set is not given. Okay. So coming to the domain of this, what is the domain? First element. What is the first element of the order pair? 0, 1, 2, 3, 4, 5. So write down 0, 1, 2, 3, 4, 5. Next comes range. What is the range? It is the second element of the ordered pair. Which is the second element? 5, 6, 7, 8, 9, 10. Repeat that. 5, 6, 7, 8, 9, 10. We can regard capital R to be in a codomain also. Okay, no problem. But no need to mention. Now, better work out this, then you will be sure no that your entries are correct. Okay. Now let us move on to model question paper number 2. It is a fill in the blanks 1 marker question. Question is asking that let A and B be given two sets, the number of relation from A to B. Recall the formula. Number of relation from A to B, the formula is what? 2 to the power of number of element in A into number of element in set B. How many elements do we have in set A? 3. So write on 3. Then into how many elements do we have in B? 2. 3 2s are 6. How much is 2 power 6? Multiply 2 2s are 4. 4 2s are 8. 8 8s are 64. Yes. 64 such relation possible. Am I right? 2 2s are 4. 4 2s are 8. Again 8 into 8 is 64. Yes. Job done. Make a note of this. Dear students, now let us move on to model question paper number 3 on relations problem. Question number 30, as you know, it is a 3 marker question. It is surely from part C. Question says that let A be given as set of all element 1, 2, 3, 4, 6. Be careful, 5 is not there. So it should not happen now. I solve, you wrote 5 also in the solution, then answer wrong. Why? You have solved for some other question. You have to solve for the question given in the question paper, not something like you will solve, you will give your own number there. Okay. Let R be a relation on set A defined by, what is the definition in this problem for relation? Understand this. R is ordered pair where both A and B come from the same set A, which is nothing but this element 1, 2, 3, 4 and 6. B is exactly divisible by A. So I want only that if I'm going to divide B by A, nothing but B divided by A should be exactly divisible. Nothing but it should be a multiple. Okay. Then write in roster form, domain and range. See the solution. I know many students will mess with this problem. Very simple, I will say. When I'm saying divisible, no. For example, is 4 divisible by 2? Yeah, 4 1s are, 4 2s are. I mean to say 2 1s are, 2 2s are. Correct? No, I mean to say 2 1s are, 2 2s are. Why it happened? See, 2 2s are 4. So 4 is a multiple of 2. So in place of dividing, no, think as what? Multiple. For example, first number is what? 1. Start multiple of 1. 1 1s are 1. Yes, it is there. Then 1 2s are, I'm writing like this. 1 1s are 1. So this is my first element x and this is your y. I hope this point is clear. Next, 1 2s are 2. So x and y. Yeah, 1 comma 2. Next, 1 3s are 3. Yeah, 3 is also there. I will write. 1 4s are 4. 1 5s are 5. But 5 is not there, so I will not write. 1 6 are 6. I don't think this is any trouble. Trouble comes from 2 4 3. No. So it's simple. See this carefully. Again, go for 2 table. 2 1s are 2. 2 2s are 4. 2 3s are 6. So this are the number which is exactly divisible by 2 because 2, 4 and 6 are multiple of 2. I hope this point is clear. So I am going to continue here. This is your x and this is your y. So what I write? 2 comma 2. Next 2 comma 4. Next 2 comma 6. Next see the number. See 1 over 2. Now 3. Go to 3 table. 3 1s are 3. 3 2s are 6. First I am checking again. Oh, 3 6 only I want. 3 3s are 9 is also there. But I want only 1 2 3 4 6. So this is x and this is your y again. Correct? No. 3 comma 3. Then what? 3 comma 6. Next is what? Which number? 4. 4 1s are 4. 4 2s are 8. 8 is not there. 6 1s are 6. 6 2s are 12. 12 not there. Stop. Over. R is ready. Now I have to write what? Domain. They asked to find domain. First part is done. Second part of the solution, I want domain. What is the domain? Don't forget in the ordered pair, always the x coordinate is domain. And what is y coordinate? Range. So, domain. See here the first coordinate. In the first coordinate, the first element, you see 1 here, then 2, then 3, then 4, then 6. So, domain is 1, 2, 3, 4 and 6. I also want range. Okay, that's a problem. Coming to the range, see carefully. So second element, y coordinate, no. So here 1, 2, 3, 4, 6. Again here also 2, 4, 6, 3, 6. So ultimately 1, 2, 3, 4, 6. In this problem, domain and range are same, as well as codomain also same. So this is the end of the solution for this problem. Make a note. Dear students, having completed problems from relations from the model question paper problems, now we are going to go ahead with functions. Actually, we have only one question from functions. As you know, 5 marker questions are assured from concept of functions. First, let us complete this. A function f is defined by f of x is equal to 2x minus 5. Then the value of f of 0 is, see, in place of x, what do we have? 0. So the pre-image is 0. I have to find the image, correct? So f of x is given as 2x minus 5. So find the value of f of 0. So we are going to put x is equal to 0 in this equation number 1. When I do so, we will get 2 times of 0 minus 5. 2 into 0, 0 minus 5. The answer is what? Minus 5. Therefore, f of 0 is minus 5. Option C. Okay. Make a note. Dear students, having completed model question paper problems on 1, 2 and 3 marker, now it is time for 5 marker question. But here I just thought that in place of completing only the 3 5 marker question on the graph, the functional graph, it's better to discuss all the 8 graphs. As of now, I'm going to discuss. Surely I will also quote which particular graph has been asked in which model paper. Now, why am I going for all the graph? Don't forget, other graphs also important, and surely upcoming after your exam, you will be a second PUC student, and these graphs are primary graph. So that's the reason I thought let I complete all the 8 graphs in detail. Okay, let us start with that. Now the first graph. Okay, let us take the heading, some important graphs, functional graph. I'm using function graphs because, as you know, all these are a function only, because every element will have only one image. Okay. Now in this, the first graph is identity function. Now what is this identity function? As we discussed previously, when I say function, I'm going to have, let us write it here, always f will be a function from where to where? A to B. Always my first set will be domain and the second set will be codomain. So this is always there for all the graphs. Okay. So identity function is defined as, definition of this, a function f from R to R defined by y equal to f of x is equal to x. This is where x belongs to a real number. All the x belongs to a real number. Before I go ahead, now let us try to spend some time on what is the meaning of y equal to f of x. Okay, let us take it here. Whenever I write y is equal to f of x, here we have two variables. One is the x, other is the y. X is called independent variable. Independent variable. Whereas y is called dependent variable. Now why the name so? See, for different values, write properly. For different x values, I'll have corresponding y value. And what is the meaning of this? I am writing y in terms of x or a constant. Okay, there's the meaning of this. So now having this, let us proceed. So y is a function of x, and that is x here. So it has equate this. So y is equal to x. This is the identity function. I have to plot the graph of this, then find the domain and range. So best practice will be to plot by taking a tabular box. Let us have your x value, then y value, and then the coordinate. Now you see carefully, one by one. Always try to take positive value, negative value, and 0. Then you will cover the entire x and entire x-axis. Nothing but positive, negative, and 0. So when x is 0, put here. When x is 0, x is 0, y is also 0. So the coordinates is 0, 0. When x is 1, y is equal to 1. So the coordinate will be 1, 1. When x is equal to 2, put again, y is also what? 2. So 2, 2. When x is equal to minus 1, what? Y is also minus 1. So minus 1, minus 1. Let's take one more here. When x is equal to minus 2, y is also what? Minus 2. So the coordinate is minus 2, minus 2. So always try to prefer positive and negative, including 0. Now let us plot the graph. Okay. Make sure in examination, take a pencil, scale, eraser, sharpener, spend some time, draw the graph neatly. Okay. Now, 1, 2, 3. Minus 1, minus 2, minus 3. 1, 2, 3, and one negative value enough. Okay, minus 2 and minus 3. Now, 0, 0. Yeah, 0, 0 is the origin. 1, 1. X is 1, y is 1. So the point is here. 2, 2. X is 2, y is also 2. So here. Minus 1, minus 1 somewhere here. Minus 2, minus 2 here. Now I have to join all this, and we are going to get a line passing through the origin, as you can see here. Okay. So I'll take the point here. So you have to make sure when you're drawing, no, is it looking straight? Yeah. Fine. So when you're drawing, make sure take a scale and draw it. Okay, this is y equal to x, and the line is not going to stop here, it will just move on. Okay, now how to find the domain and range? Listen carefully. How to find domain and range? Very simple. As we discussed that whenever we have any point x comma y, x will give you the domain and y will give you what? Range. Correct? No, this already we discussed. So now what we have to do is see the graph along x-axis up to where the graph is covered. That will give you domain. And for y-axis up to where the graph is covered, that will give you range. Same from here itself. See your x-axis is from minus infinity to plus infinity. For all this x value, you have the graph. Again, for all this x value, you have the graph. Therefore, for this, domain of the problem will be R, which is also minus infinity to plus infinity. In the chapter 6, I have spoken about this. Now, why not like this? Who knows, for one marker, they may have domain, they might have given either R or this. Both are same. Coming to range, see your y-axis. For all this y value, graph is present. Again, for all this y value, graph is present. So, the range is R, open interval, minus infinity, comma, plus infinity. Okay, both are not taken. This is the first graph which is done. Now, what is the marks distribution? Definition will carry 1 mark, graph will carry 2 mark, domain and range each will carry 1 each. So 1 plus 2, 3, 3 plus 2, 5. That's it. Now let us move on to the next, that is modulus function. The definition of this function is f is a function from definition here. F is a function R to R defined by y is equal to f of x is equal to mod x. Let us take the first and the last. So y is equal to mod x. Now what this is saying? See, mod is going to convert a negative number to positive and mod of 0 will be 0. I will try to explain both the ways, okay, from the definition and what we have understood with the notation. So mod x will be plus x when x is positive. Mod x is minus x when x is negative. Mod x is 0 when x is 0. Now try to understand why there is a flower bracket given here and why there is not any flower bracket here. I want to understand this one now itself. See, whenever my function, okay, f behaves more than one manner, what do you mean by that? Here for all the real number x, y equal to f of x is x only. But here it is not the case. Here we have different condition. So if I talk about number line, 0 is here, plus infinity this side, minus infinity this side. As you can see that when x is positive, my function will be plus x. I think mod x is plus x. So here it is plus x when x is positive. Whenever x is greater than 0. When x is less than 0, I think but this side, my mod x is minus x. And when x is equal to 0, x is also what? 0. So we have three different behavior. One, positive x, second, negative x, and third is equal to 0. So since I have got more than one behavior, flower bracket is given. So whenever flower bracket is given, you should understand that we have condition. Under different condition, my function is behaving differently. So my function behaves more than one manner. And that condition is specified here. Now often students have the confusion, should they see the values of the function or the condition? First you should see the condition, then go ahead. Now before we plot, let us try to understand how this definition is working. Now, as we know, modulus means convert negative to positive. Output is always non-negative. If I talk about mod of minus 2, so we just write plus 2. Why? Convert negative number to positive. Similarly, what is mod of plus 2? Yeah, it is plus 2 itself. Convert negative to positive. Now, I want you to understand this with this definition. Okay? See carefully. If I just see in place of this x, what do we have? Minus 2. Correct, no? We have minus 2. So, x is equal to minus 2 we have. Now, we have to first check the condition. Among all this, x is equal to minus 2 means what? Negative number. Among these three, negative number is here. So, see carefully. So, I'm going to substitute here. Mod of minus 2 is equal to, when x is negative, minus of x. So I will write minus. I will write what? Minus. Then x. What is x here? Minus 2. So I write minus 2. Minus to minus plus 2. That's how we get. This is how we are going to get. Come on, let's take one more number. Mod of minus half, which is plus half. Let us try to get from this. In place of x, minus half. So x negative here. So minus already there. Then minus half. Minus to minus plus half. Okay. Similarly, come to this. Mod of 2 is 2. How? Here, in place of x, what do we have? If I compare with this, in place of x, what do we have? 2. So 2 is positive. Correct? So among these three are positive here. So mod of x is plus x. So mod of 2 is plus 2. Plus 2 or 2, both are the same. That's how we get like this. Okay. So I hope the things are clear. Now let us go for the table. When we are going to compute, we are going to use this logic only. But I have made you understand how this formula works. So again, let us have a table. for negative and positive. Always we will take negative value as well as positive value. Only then you can cover, you can see the negative part of x-axis. Don't fix yourself only to positive. I know from school days only positive, positive. Yes, yes. Now, what is x? Which type of number x is? A real number. Now, x, when x is 0, mod of 0, 0. So 0 comma 0. When x is equal to 1, mod of 1 is 1 itself. When x is equal to 2, mod of 2 is 2 itself. So 2 comma 2. When x is equal to minus 1, mod of minus 1 is plus 1. So minus 1 comma 1. When x is equal to minus 2, mod of minus 2 is plus 2. So minus 2 comma plus 2. Okay. Now let us plot the graph of this. Now coming to the graph of this. Make sure draw x and y axis perpendicular. Okay. In examination, use scale and pencil. Okay. 1, 2, 3. Minus 1, minus 2, minus 3. 1, 2, 3, and here one negative value. Fine. Now let us plot it. 0 comma 0 here. 1 comma 1, yes, first quadrant. 2 comma 2, again first quadrant. Okay, I have one doubt whether the student remembers or not all the quadrants. See carefully. In the first quadrant, both x and y is positive. In the second quadrant, x is negative and y is positive. In the third quadrant, both x and y is negative. In the fourth quadrant, x is positive and y is negative. Okay. So you can see 1, 1, both are positive. So I wrote it in first quadrant. 2, 2, both are positive. I wrote in first quadrant. Minus plus. Minus plus. It is in second quadrant. So minus 1 and then 2 here. Okay. Minus 1, minus 1. Minus 1 plus 1. Okay. Then minus 2 and then 2. Join this. If I join this line, again I get a straight line passing through the origin. And here itself you can see when x is positive, yeah, this is positive part of x-axis, y is plus x. So y is equal to plus x when x is positive. When x is negative, nothing but this part, y is equal to minus x. So y is equal to minus x. Now from the same logic what we have discussed here, we have to talk about what? Domain and range. How to find domain? See the x-axis up to where the graph is covered. For all this negative part, negative infinity to plus infinity, if you see, for all this negative part, graph is present. And again, for all this positive part, graph is present. At 0 also, graph is present. Therefore, the domain of this is R, which is also same as minus infinity to plus infinity. What about the range? See carefully. Do we have any graph here? Black color, what I have drawn the graph, do we have here? No. It is just starting from 0. 0 to where? Infinity. As and how I move up, the graph also moves up. So the range is closed interval 0 to infinity. Okay. So with this, modulus function completes. I think it has come in one of the models. Come in model question paper number 2. And it is question number 39 for 5 marks. Okay, question number 39 for 5 marks. All these are 5 marks only. Okay, anyone coming is 5 marks only. Okay, fine. Make a note of this. Yes. Okay, dear students, now let us move on to the next graph. I have written this one for some purpose. First, let us start with this. Next one is constant function. Now, what is constant? The word itself says constant. It should not change. So, the definition of this is f is a function from R to R defined by y is equal to f of x is equal to some number c. And this is happening for all the x values. Try to understand. Last time we had for the first one identity x here, but here we don't have x, some other constant, some constant is, that is a variable, but here is a constant, c is a constant. Now, let us take this. Before I take, let us take one example to understand better. If I take one constant y is equal to, let us suppose 7. So see here, if I take a table for this small table, I will take it here. See carefully to have better clarity of this. If I take x here and then y here and then I am plotting the point. See carefully. When x is equal to 0, do we have x here to change? Last time we had y is equal to x, due to which as I now I have varied x value, y also got changed. But here, do we have x? No. So y will remain 7. So 0 comma 7. Again, if I take y is equal to some 2, again, I mean to say x is equal to 2, y is again what? 7. So 2 comma 7. If I take x is equal to minus 3, do we have x here? No. So y will remain 7. So I'll get minus 3 comma 7. So if I plot the graph of this, again 0, then 1, 2, 3, minus 1, minus 2, minus 3, and here let us suppose 1 here, then 2 here, like that, somewhere here 7. So I have not written the remaining numbers. Now 0 comma 7 is here because any point lying on y axis is of the form 0 comma y. Any point lying on x axis is of the form x comma 0. So now you see carefully, 0 comma 7 here, 2 comma 7, so 2 here and 7 somewhere here, minus 3 comma 7 somewhere here. Now if I join this, it's a line parallel to x axis. It's a line parallel to x axis, and you see for different values of x at 7, I have a line parallel to x axis. So I have just taken one example to make the things clear. Now we'll go for general. See carefully. Again, a table I will take x value here, y value here, and x comma y value here. Now x is equal to 0. Let us have the same values. So this is y equal to c, correct? No. Do we have x here? No. So y will remain c only. So 0 comma c. Next, if I take next value, x is equal to 1. Do we have x here? No. So c remains c, 1 comma c. When I take x is equal to minus 1, again here it is c. Same logic what I just said here. And if I take x equal to 2, y is again c, so 2 comma c. When we take x is equal to minus 2, it's again c. Last time it was not like that. I mean to say, coming to which function? Identity function. Whatever we had for x value, we got the same because x was there, so it was changing the value. Here the values are not changing. Now again, let us try to plot the graph of this. C is any real number. Okay. So let us move on one by one. See carefully, make sure, draw the things by using scale and pencil. Don't draw rough diagram. We carry 2 marks. If diagram is wrong, no domain, no range to see. You can see domain and range we are seeing from the diagram only. Now from here, see, sir, here 7 was you have taken a particular number 7, so you have plotted here. What about this? C you can take anywhere on y axis because it is y equal to c. So let us suppose I will take somewhere c here. Okay. Now 0 comma c, it will be here only. 1 comma c, so exactly at here 1 comma c. Then minus 1 comma c somewhere here. 2 comma c somewhere here. Then minus 2 comma c. Yes. Now join this. When you join this, you get a line parallel to which axis? X axis. This is y equal to c. Okay. So geometrically, constant function will give a line parallel to x axis. Now, what is the domain? Domain of this. See all x values. For all these x values, graph is present. So domain is R. See range value. Do we have any graph below C? See carefully. Black color. Whatever the line have drawn. No. Above C? No. Only at C we have got. And it's a singleton set. Who knows, for 1 mark they may ask, which is the function whose range is singleton set? Which is the function whose range is singleton set? And is what? Constant function. Okay. Make a note of this. So I have written this one so that you can understand. Since x was present here, as and how I varied x value, y also changed. But since x is not present, as and how I varied x value, y have remained same. Okay, in both. And here also, if we just talk about what is range, And domain, for this problem, domain is again what? R only, because same reason, for all this x value, graph is present, and this graph is y equal to 7. So what about the range of this? Set number 7. Okay, set with the number 7, singleton set it is. Okay, make a note of this. Okay, dear students, now let us move on to the next function, and this next function which I am going to take, the fourth one, that is signum function or sinum function, whatever way you want to pronounce, but the spelling should be correct. And this has come in model question paper number 1, question number 39 for 5 marks. Okay, so I have written this graph because I'm going to take some information, some knowledge from here to go for signum function. Now, definition of signum function, again, f is a function. Definition of this, f is a function from R to R defined by y is equal to f of x is equal to mod of x divided by x, where x is not equal to 0, and 0 when x is equal to 0. And again, what is x? Real number. That's what you can see now. 0 and non-zero, all are covered. Now here, see carefully, in the numerator you have got modulus. So recall the definition of mod. As soon as you see this, see, actually the mod can be in denominator also. I mean to say that this can be also be like this. No problem. Okay. Now let us confine ourselves to this. Okay. Now, since we have mod, recall the definition of modulus. Mod x is plus x when x is positive, minus x when x is negative, 0 when x is 0. Before I go ahead, let I try to make you understand how to remember this formula also. Very simple, man. Dear students, see, under the term, under the modulus, who is that? X. So here, modulus is removed depending on negative, positive. Mod of 0, 0, all will remember. Now, assume for a while that I am inside the mod. I am inside the mod, and recall some basic sign. What is minus into minus? Plus. And what is plus into plus? Plus. My ultimate thing is, if the number is non-zero, modulus will give positive for non-zero. Okay, for 0 it is 0 itself. Now you see carefully. Let us assume for a while that I am inside the mod. I am inside the mod, and my target is to become positive. My target is to become positive. I am under the mod. I am already negative. I am already negative. So which sign? I am already negative. Which sign should I multiply to make myself positive? Minus. Minus to minus plus. That's all you can see. When it's already negative. To remove mod, x is multiplied with minus sign. To remove mod, x is multiplied by minus sign. Similarly, again, second instant, I am inside the mod and I am already positive. I am already positive. I want to remove the mod, but don't forget, mod wants always positive. So since already I am positive, which sign should I multiply to become positive? Plus into plus, plus. So I have to multiply with plus sign. So mod, when I am removing, for x I am giving plus sign. I hope this logic is clear. Huh? Fine. Now let us move on to this. See carefully. Here, y equal to f of x. Mod is there where? It is there only in the numerator. Now I am not going with this, only this one I am going to go ahead. Now see, here x is not equal to 0 they have given. So here we have got two cases. X can be positive, x can be negative. Anyway, but x equal to 0, it is 0, they have already mentioned. Now, denominator is no mod. So I can write for this, denominator is x. For this also I can write x. Now comes numerator. When x is positive, mod x is, when x is positive, mod x is plus x. So in place of mod x, it should be what? Plus x. Similarly, when x is negative, mod x is minus x. So in place of mod x, it should be what? Minus x. So now you see, this x which is there, both will get cancelled. Let us change in this overlapping far away. Now see carefully. Can I cancel both? Yeah, both are same. I can cancel because it's a non-zero number. So I'll get plus 1 for this. And again I can cancel this x and this x, I'll get minus 1. So my function will be y is equal to f of x is equal to plus 1 when x is positive, minus 1 when x is negative, 0 when x is 0. Okay. See, I'm trying to do in this revision class such a way, no, second PUC functions relation should be the perfect. Okay. Now, let us take a table. X value, y value, and then x comma y. Now, again, positive value and negative value. Let us understand better what is happening. Let us understand better. See carefully here. X value 0. See carefully, you have to understand. When x value is 0, yeah, y is also what? 0 only. So write on 0. See carefully now. If I take x is equal to 1, check here. X is equal to 1 means what? Positive or negative? Positive. Yeah, positive. Y value is plus 1. So write on plus 1. So 1 comma 1. If x is minus 1, among this where is negative? Here, x is negative. So y value will be what? Minus 1. So write minus 1. So minus 1 comma minus 1. Now take 2. 2 is positive or negative? Positive. Among the three, where positive? Here. And y value is what? Plus 1. So when x is equal to 2, 2 is positive, y is also again what? Plus 1. So I'll get 2 comma plus 1. Next, if I take minus 2, x is negative. Among the three, this one. So when x is negative, y is also minus 1. Y is minus 1. So minus 2 comma minus 1. And you should also understand, since you had x here, the value got changed, but the values lying only having, we have having only three values, 1, minus 1, 0. Now let us go for the plot. See carefully the plot. Pay attention, listen carefully. Now see carefully. When x is equal to 0, y is also 0, nothing but origin here. When x is equal to 1, y is also 1, 1 comma 1 here. Then minus 1 comma 1, minus 1 here. Then 2 comma 1. And then minus 2 comma minus 1. Minus 2 comma minus 2 comma minus 1. So if you just see, whatever positive number I take, see here, whatever positive number I take, nothing but right of y-axis, always the value is what? Y equal to 1. Come here. Y equal to 7 means a line parallel to x-axis. It was throughout the real number r. Correct? No? Similarly here for C. But now I am confining that when I am going towards right of y-axis, nothing but positive part of x-axis, my value is always 1. So I am going to draw a line parallel to x-axis, the value is y equal to 1. But x should be positive. Don't forget any point lying on the y-axis of the form 0 comma y. X is 0. X should not be 0. X should be positive. So at here, purposefully I'm just erasing and writing an open ball so that you remember there is an open ball here. Okay. Similarly, here after joining, whenever x is negative, y value is what? Minus 1. So all for negative value of x-axis, value should be minus 1. So draw a line parallel to y-axis at y equal to minus 1. And here I have to again shade because x is strictly less than 0. It's not, x is not 0. So this is the graph. And from here, what's the domain? See the domain of this. Domain of this is all real number. You can see from negative infinity to positive infinity. From left to right, the graph is covered. See the range of this. Which axis you have to see? Y-axis. We have graph only at minus 1, then 0, and then 1. Don't forget, origin is what? 0 comma 0. So y value is 0. So my range is minus 1 comma 0 comma 1. This will be the range. Okay, I hope it's clear. Make a note of this. Dear students, having understood signum function, now time has come to move on to the next function, that is greatest integer function. So the function is fifth one, greatest integer function. I would like to take some time on this to make the things clear. See carefully. Many students have a doubt on this, so I thought I will just try to take one example, a practical example. Assume that there is a city and there, as you know, we need water. So there is a department having the control over the water to be supplied to the city, and one person is assigned here that he has to comment about what is the level of the water in the tank, and he has to be precaution that if it is less than, let us suppose 0, he has to inform so that the water can be filled here. So here 0 is there, 1 is there, 2 is there, -1 is there, -2. So as soon as it comes below 0, he has to inform that the water is reducing, the tank is getting empty. But here's one problem: he don't have any knowledge about other than integers. He don't have any knowledge about what? Rational numbers. Or I can say that in a scale they have not given anything about rational numbers. Okay. So now, since full water is present here, now let us suppose the water level is here. So the symbol for greatest integer function is rectangle bracket. Okay, so I'll use that only. So I want to know what is the water level. So he sees, okay, at 2 the water level it is. So answer is what? 2 only. Okay. Now let us suppose the water level is here. Don't forget, he don't know what? Rational numbers. So now let us suppose here, no, it can be anywhere in between, no. So let us suppose this is 1.5, we know it, 1.5, but he don't know. Okay, 1.4 I will take, you may think as midpoint, so I'll take 1.4. So if I take 1.4 here, he don't know rational numbers. So if he said 2, it's a wrong information. So he should go to the nearest integer. He cannot go for all this, then it is totally wrong. So we will say answer is what? 1. Okay, immediate below, or the left one, I guess, yeah, in terms of number line. Let us suppose the water level is here. Then answer will be 0 only, because exact 0. Let us suppose the water level is somewhere here, which is let us suppose -0.8 it is, but he don't know the integer. So what's the answer from him? -0.8 will be okay. He cannot say 0, it will be a wrong answer. Means yeah, because this much of water is not there. So he'll say -1 to be safer side. Correct? Like this here also, if I say this one, exactly -1. So answer is what? -1. This is what actually the greatest integer function. If I talk about in terms of number line, 0 here, 1 here, 2 here, -1 here, -2 here. See carefully, whenever it is integer, answer is the same. But whenever it's a fraction, for example, even can be less number also, okay? I can say non-integer number. If I say 1.4 is somewhere here, and my answer 1.4 is here, correct? No, and my answer is what? 1. Immediate left. Similarly, -0.8 is somewhere here. My answer was -1. Immediate left. So coming to greatest integer function, if the number given to you is not an integer, my answer is left integer. Bajuwala. Left. Immediate left. Okay. So I hope this logic is clear. Now with this, let us start the greatest integer function. Okay. Okay, fine, dear students. Now let us move on to greatest integer function. Okay. Now the actual graph starts. See carefully. Understand the things. Okay. Now I will plot the graph. First, the definition. What's the definition of greatest integer function? F definition. F is a function from R to R and defined by y is equal to f of x is equal to rectangle bracket x, where rectangle bracket whatever we get inside is greatest integer function, greatest integer, it is the greatest integer, sorry, less than or equal to the number which is present here. Equal when, as you can see, whenever it is integer, and when less, whenever it's not an integer. Okay. So now let us plot the graph. And here we are going to use the concept of constant function. See carefully, pay attention. Okay, see carefully. Now, if I take any number x between 0 to 1, between 0 to 1, close interval 0, open interval 1. As I said here, no. So it is 0 to 1. Always I said what? Baju wala, left. So answer is what? So the greatest integer value, y is right here, y is rectangle bracket x. Okay. So the value of this will be 0 always. Correct? 0 always. If I take x belongs to, let us plot simultaneously. Between 0 to 1, y value 0. Any point lying on y-axis is of the form x comma 0. So y is always what? 0. So between 0 to 1, my graph should be here. So I am shading here because 0 taken, 1 is not taken. So open 1 and then join this constant function. Piecewise it is. When x is belonging from 1 comma 2. So 1 comma 2 is here. My greatest interval what? 1 only. So y value will be 1. So y is equal to, don't forget, this all are your y values. So y equal to 1 here, y equal to 2, y equal to 3, y equal to minus 1, y equal to minus 2, y equal to minus 3. So 1 to 2. Yeah, 1 to 2. What's the value? Y equal to 1. So between 1 to 2, y is 1. So just exactly go up and here. Put a dot and then here, this should be shaded and this should be open. Why shaded? Close. Recall chapter 6. Close interval means value taken, open interval means value not taken. So join this constant function. Between 1 to 2, y is equal to 1 is the constant there. Then again between x 2 to 3, close 2, open 3. Yeah, come on, 2 to 3. If I take a number here, all the numbers lying here will jump here only. Correct? No? So y value is what? 2. Y is equal to 2. Right here. Plot it. Okay. Next, when x is equal, x belongs to, yes, minus 1 to 0. Interval concept detail we have discussed in chapter 6. Go through once. So y value, see, minus 1 to 0. Answer is what? Minus 1 only. So come to minus 1. Between minus 1 to 0, yeah, here and here. I have to close here. Minus 1, yeah, minus 1 should be closed. 0 should be open. Yes, join it. Then x belongs to what? Next number, minus 2 to minus 1. Close interval minus 2, minus 1, open interval. So y is equal to minus 2. Y is equal to minus 2. Between minus 2 to minus 1. So here, again, close here and open. Join it. Lastly, okay, I think sufficient. Or we'll take one more, no problem. X belongs to close interval minus 3, comma, open interval minus 2. The value will be minus 3 to minus 2. Plot it here. What will happen? Minus 3 to minus 2 will be always left. The same it was left here, minus 2. So here it is now minus 3. Minus 3, yes, and here. Here open and here close. This is the graph of greatest integer function, and you can just see a person comes here, tuck, 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 climbs the ladder. This is also known as step function. Okay, just for your general knowledge. Now come on, comment on domain and range. What is the domain and what is the range? For domain you have which axis? X-axis. Come on, see x-axis from negative infinity to positive infinity. See, for example, if you say this, for this particular number, graph is there. For this also graph is there. Even if I go left to minus 3 also graph is there. And it is still rightmost also, so domain will be R. Coming to range, see y-axis. See, y equal to minus 3 graph is there, y equal to minus 2, minus 1. And this is, don't forget, this coordinate is, this particular will be y is equal to 0. Correct? No, the origin. So it is shaded here. Okay. So y equal to 0, y equal to 1 here graph, y equal to 2, y equal to 3, all. So the answer is what? Integer. You know, if you just examine for this particular question, range is leaked in the question only. How? See carefully. Greatest integer. Again, in the function name itself, answer is leaked. That range is what? Integers. And one more thing, no, coming to all the graphs so far, even next to also, domain is always R. You can remember like that, no? Domain is always R, except the last graph, which we'll discuss shortly. So make a note. I hope the things are very clear. Make a note. Yes, dear students, now we are ready for the next three graphs. All are under polynomial, and the last one is under rational function, which is a special rational function. Now first let us try to understand what is polynomial function. I'm using the word function, nothing but it will have only one image. All are functions graph, okay? Now, the definition of polynomial, P of x, as we had f of x, here I think P of x, P for polynomial, and here the variable is x, and it's an expression of this form a0 plus a1x plus a2x square plus a3x cube, and moves on, lastly an x power n, where this a0, a1, a2, a3 up to an I will call as ai's. It's a real number. When I is equal to 0, a0. When I equal to 1, I equal to 2, will get this. And this is the n degree polynomial, provided this x power n multiple is not equal to 0. And what about the power n? You can see here, 1 here, sorry, here 3. Then 1 here, I repeat, 1, 2, 3, and there's no power for x, nothing but x power 0 I can say. So n is a whole number, or I can say it is non-negative integer. Next, having this understood, observe the power should be always whole number. Okay, that means there is no case of root x, etc. Okay, now you see carefully, we are going to have two special graph on this. One is parabola, nothing but a quadratic polynomial. Okay, every quadratic polynomial is what? Parabola. When the graph we get is called parabola. So I can give both the names. Anyone can come in the examination, the name. Usually this will be the name. Now what's the definition of this? Now y is equal to f of, okay, first let us define the definition. Okay, f is a function from where to where? R to R, defined by y is equal to f of x is equal to x square. Degree of quadratic polynomial is highest degree is 2. Parabola also highest degree is 2. Now let us take first and the last. Y is equal to x square. So x value, then y value, then x comma y. Let us try to plot the table for this, and then we'll plot the graph for this. Ready? Focus. When x is equal to 0, y square, x, put here x, 0 square is 0. So we'll get 0 comma 0. When x is equal to 1, 1 square is 1, so I'll get 1 comma 1. When x is equal to 2, 2 square is 4, so I'll get 2 comma 4. When x is equal to minus 1 whole square is plus 1. So minus 1 comma 1, I repeat, minus 1 the whole square is plus 1, so I wrote that. Then when x is equal to minus 2, what is minus 2 the whole square? It is plus 4. Square will convert negative to positive, 2 square is 4. So we'll get minus 2 comma 4. So this we have got, we are putting the values here, and we have got the corresponding y value. Let us plot the graph here. When we want to plot the graph here, one, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, 4, 5, moves on, minus 1, minus 2, moves on. Now you see carefully, 0 comma 0, it is here. 1 comma 1, yeah, 1 and 1, it's here. 2 comma 4, 2 is here and 4 is somewhere here. Okay. Then minus 1 comma 1, it's here. Minus 2 comma, this is minus 2 minded, 2 comma 4. Join this. This is a smooth graph. Don't do scale while drawing the graph. For all the remaining 5 till greatest, starting from identity function till greatest integer function, all the graph you are going to draw by scale only. All are straight line. Y equal to x, yes. Then y equal to modest straight graph. Y equal to c constant graph. All are straight line. You will draw by scale and pencil. But here no scale. Only for x-axis, y-axis scale is required. Now when you draw, it should be a smooth graph, freehand graph. Yes. This is, and it will extend. It's not that we're going to stop here. It will extend like this. Why? It stop. I have stopped at 2 and minus 2. I'm always taking 0, positive value, negative value, so that we cover everything. What is the domain of this? Which axis we have to see for domain? X-axis. See, for all negative value till positive value, for all this graph is covered. Again, for all this graph is covered. At 0 also graph is covered. Domain is R. What about the range? Do we have any graph from minus infinity to 0? No. It starts from 0 to infinity. So close interval 0 to infinity. Make sure learn all the domain and range. Who knows, for 1 marker question might come? Okay. So this is about parabola quadratic. In polynomial, we have one more. That is on cubic polynomial. Cubic polynomial. Let us know the definition of this. The definition of this is, let f be a function from R to R defined by y is equal to f of x is equal to x power 3. When I say cubic, highest degree should be 3. And again here also, what is x? A real number. Here also, what is x? Real number. Always real number. Now let us plot the graph of this. For that, first we need the table, x value, y value. When x is equal to 0, and I want x comma y also, right? We need x comma y also. When 0 cube is 0, so I'll get 0 comma 0. Then x is equal to 1, 1 cube is 1, so 1 comma 1. When x is equal to 2, 2 cube is how much? 8. So 2 comma 8. When x is equal to minus 1 the whole cube. Just here, minus 1 the whole cube is minus 1. Then when I take x is equal to minus 2 cube is minus 8. So here we have values both on x, positive and negative part of y-axis. Let us try to plot the graph for this. See carefully. Listen carefully. 1 here, 2 here, 3 here, minus 1, minus 2, minus 3, 1, 2, 3, 4, 5, 6, 7, somewhere here 8, then 9. Similarly, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, and somewhere here minus 8. There is a y dash here. Now let us plot the point first. So 0 comma 0, it's here. 1 comma 1, it's here. 2 comma 8, 2 is here and 8 is somewhere here. Let us write it. 2 and 8. Yeah. Then minus 1, third quadrant, it's somewhere here. Minus 2, minus 8 will be somewhere here. Okay. Join this. When we join this, sorry, let minus 1 here, no. When you join this, this is the cubic graph, y equal to x cube. Now come on, see the domain and range of this. Domain of this, see which axis? X-axis. See, for all negative value of x, graph is present. For all positive part of x, graph is present. So domain is R. What about the range? Which axis? Y axis. For all this y value, graph is present. All the negative y value, graph is present. Range is also R. Okay. So both the graph on polynomial completed. Make a note of this. One more thing to make a note. This question has come in model question paper number 3. Question number 40 means to say 39, sorry, 39 for 5 marks. They have asked the definition of polynomial and then cubic. So I have already given the definition here. Okay. So yes. So make a note of this. Okay. Dear students, now we have come to the last graph, that is rational function. What is rational function? See, we have heard about rational number. Similar to that. First, rational number definition is what? Any number of the form P by Q, where both P and Q are integer and the denominator Q is not equal to 0. Similar to this, rational function. Any function of the form f of x is equal to p of x divided by q of x, where q of x is not equal to 0, and both p of x and q of x are polynomials. Okay, it's not integer, it's a polynomial. Now, one such example we have got is f is a function from r minus 0 to r defined by y equal to f of x is equal to 1 by x. Now, it's not a polynomial because if I take to the numerator, I'll get this as what? First, x is not equal to 0. 1 by x will be what? X power minus 1, and minus 1 is not a whole number. Okay, fine. So it's not under polynomial. Now we are going to plot the graph of this. See carefully. Again, since x should not be equal to 0, see this carefully. X here, y here, then x comma y. When x is equal to 1, I'll get 1 by 1, 1 itself. When x is equal to 2, 1 by 2. 1 by what? 0.5. So 2 comma 0.5. When x is equal to 3, what? 1 by 3. How much is 1 by 3? Minus 0.3 plus 0.3. So 3 comma 0.333, but I'll just approximate to 0.3. Then minus 1, same value will get minus 1 here, minus 1 comma minus 1. Correct? Now put x is equal to minus 1, 1 by minus 1, minus 1 is what? Minus 1. Then x is equal to minus 2. So I'll get 1 divided by minus 2. On simplification, get minus 0.5. So minus 2 comma minus 0.5. Next, when x is equal to minus 3, what will get? 1 by minus 3. So value is minus 0.3. So minus 3 comma minus 0.3. Now we are ready to plot the graph for this. Let's plot the graph. Now see carefully. Okay, first numbering 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2, minus 3. We'll try to take one number very close to 0 to understand better. So if I take x is equal to 0.1, put here. When I want to know what is y equal to 1 by x. When x is equal to 0.1, this will be y is equal to 1 divided by 0.1. 0.1 is same as 1 by 10. This 10 will jump up. So I'll get 10 here. So this is 10. 0.1 comma 10. Similarly, if I want to know what is for minus 0.1, I will get minus 10. Why? See, as soon as I put x is equal to minus 0.1, wherever 0.1 with plus sign, there should be minus sign. So I'll get this only. Correct, na? So let us have a very close value. I'm not taking 0 because 0 is not defined. Okay. You see, for the first time, domain is r minus 0. Okay. This is only one function. So now let's plot. See carefully. 1 comma 1 here. Then 2 comma 0.5. Yes, 0.5 somewhere here. So it will be this. 3 comma 0.3 will be here. and 0.1 somewhere here, it is somewhere on the top 10. So if I join the graph here, it will be like going like this. This is one. Okay. Similarly, -1 comma -1, then -2 comma 0.5, then -3 comma, then here, then for -0.1 it will be somewhere here. So again, if I join the graph, see carefully. This is the graph. So from here, domain. What is the domain? See, it's covering all negative value up to 0. This all negative x-axis graph is there. But at 0, you see, there is no graph here, nor above. You have to make sure the graph should not touch y-axis nor x-axis. It's very, very, very close to the graph, but not touching the graph. So I mean to say, y-axis and x-axis are not touching the graph. So graph is very, very close to coordinate axis, but not touching. It's not a tangent. Okay. Domain is r minus 0. Why 0 is not taken? Correct? No, 0 is not taken. Now coming to range, see y-axis for all this negative infinity to positive infinity, for all this y value graph is there, for all this positive y value graph is there, but at 0 there is no graph here, not here. So range is also r minus 0. So with this we have completed all the graph function. All 8 is been done. This is your graph number 8. Okay. Fine. Dear students, having completed all the 3 model question paper problems, I thought we'll take one more concept, algebra of function. It's a very important concept, and usually we have seen a 3-marker question on this as well. So algebra of functions. See, in the school days, no. First you have, after learning numbers, you have learned how to add, subtract, multiply, divide. Nothing but what is that? Algebra of numbers. Similarly here also, if I have got more than one function, how are you going to tackle? Nothing but how are we going to add, subtract, multiply, divide? So let us suppose that f is a function from a to b and g is also a function from a to b. So both domain and codomain should be same. That's the primary condition. Okay. If this happens, then first one, addition or difference for this is given by f plus g, the element x. This element will be operated on both. So f of x plus g of x. This is true for all the element x belonging to domain. Domain, as you can see, it is a. Okay. Next, difference of 2. So f minus g of x will be f of x minus g of x. Again, true for all x belonging to domain. Third, product or multiplication. Multiplication of 2 functions. So f into g of x. This will be taken for both f of x into g of x. Again, for all x belonging to the domain of f and g. Okay. Then fourth point, scalar multiplication. Scalar multiplication. To be specific, I'll do one thing. I'll mention here multiplication of 2 functions. So both are what functions only here. Similarly, here also difference of 2 functions. We can generalize for n number. Okay. Addition of 2 functions. So scalar multiplication, f and g multiplied. Okay, here scalar I said no. So one should be a number. So okay, k into g. In place of f, it is k. K is any scalar. So k as it is g of x, where k is any real number and k is a constant scalar. Now try to understand here. This x was taken for both f and g, but here it is taken only for g because k is a constant function type. Then last one is quotient of 2 functions. Quotient of 2 functions. So nothing but division. So here I'm going to have two function f by g, and on that I'm going to operate x. So it is f of x divided by g of x, where g of x is not equal to 0. So having understood this, in short, what is the summary? Whether it is addition, subtraction, multiplication or division, you should operate x to each and every term. Now from miscellaneous exercise, I have taken one problem here. So if it is coming, it will be for 3 marks. They are not asked for division, I have taken for division also. So the solution of this, see here there is no x. We are the one who should bring x. As you can see here, x is there. F and g is defined here. F plus g of x is, let us use black color only. What we are going to have, f of x plus g of x by using this definition, correct? So what is f of x? X plus 1. What is g of x? 2x minus 3. 2x plus x will be 3x. Like term should be added. Algebra. Like term means power of the variable and variable both should be same. Yes, and signs are same, so we can add. 1 minus 3 will be minus 2. So this is the first part. F plus g of x is done. Second part is f minus g of x. So this will be f of x minus g of x. What is f of x? X plus 1. Then what is g of x? 2x minus 3. Let's simplify this. X plus 1. Minus into plus is minus 2x. Minus into minus is plus 3. So what is minus 2x plus x? This is my x minded. So it will be minus 2 multiplies 1. Minus 2 plus 1 will be minus 1 into x. Then 1 plus 3 will be 4. Next is f into g of x, which is same as f of x into g of x. What is f of x? X plus 1. What is g of x? 2x minus 3. We can multiply them. X into 2x will be 2x square. X into minus 3 will be minus 3x. 1 into 2x minus 3 will be same, 2x minus 3. Simplify 2x square as it is. Minus 3x plus 2x, algebraic term. Terms are same, signs are different. Subtract 2 minus 3 will be minus 1. Into x will be minus x. Minus 3 as it is. This is f into g of x. Next we want f by g. Okay, f divided by g. So here it is f of x divided by g of x. What is f of x? X plus 1. And what is g of x? 2x minus 3. So surely 2x minus 3 should not be equal to 0. Which is that number for which it should not be 0? Or it will make 0. So 2x should not be equal to 3, or x should not be equal to 2 by 3. Okay. Yes, so make a note of this. So with this we have finished all the problems. Yes. Dear students, having completed all the concepts and the problems, these are your assignment from model question paper. Sorry, these are the assignment from question paper annual board examination of the year 2024. So question number 2, 33 and 43 are the questions from this chapter. Okay, so make sure do the assignment, study well, do the work day by day. Only then you are going to achieve the success. Okay, so all the very best, study well, and do share, like, subscribe to my YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you.